Hello, everyone. Thank you for following me until now for during this long journey of recordings. Now, this is the video where the fun part will start, is where we take advantage and we exploit the application. So in this video, the goal is now to exploit the application and take advantage of it and run our shellcode. So I have some templates which are already prepared you can use. So let's see, why is this slow now? Seems very slow. Anyway, so what we can do is I created this code so we can use it. Here, what I'm not going to go like very deep into the Python code, but at least give you an overview what we are doing. We are calling the subprocess, so we're importing that. We are creating a buffer of 28 bytes of A's. We are just printing them, printing the length of the buffer. Then we are using the subprocess to open this application and have it communicate with this one, sending the buffer, and these are the pipes for the standard input and output and error. Do the communication, so we want them to communicate, and then just print if we have any errors, etc. So we are gonna run the program and exploit it using our Python code. Okay, that's one. Let me just expand this a little bit here. Okay, and we are going to send everything to our debugger from this Python code. So all you need to do now is hit F5. So F5 will run the code and it will start. So you can see that was the buffer. Let's go back just to have a look at it. So you can see here, the buffer is this. This is the buffer, and the size or the length of it is 28 bytes. So now we are in the debugger. So what we can do, let's see if we have any breakpoints from our last time. I think we do have. Yep, they are still there. So great. So what we can do now, start our execution and see what's going to happen. So F7, or let's say F9, we go immediately to the main. F7. Okay, what did I do? I don't know what I clicked on. Okay, so let's continue. I don't want to go into this. This is preparing some stack stuff and other canaries and everything else. We don't want to go deal with that. So jump over, compare. It's more than one because we know we passed some value in the code. If you look back, let's close this one. I don't think we need it anymore. And if we go back to the code, you can see we passed we passed definitely the application to the debugger, but we also passed the buffer which has our A's. Okay, so we are sure we passed two arguments here. We have the name and the other one. So when we are going to do the comparison, it is successful. So we are not going to do the jump. Okay, so we are not going to do the jump. Now we are going to copy these values, copy. Now this one, which is the one where we call my function one. If we go back to the code, so this is going to call my function one. This is actually the code of, yep, not this one. Here, this is not, where is it? We will be just calling my function one anyway. Just go back to the code, it's somewhere, and we also have the code over here actually, so you can look at that. So it's going to call my function one, so we'll be in this one. So let's go continue. We want to jump into it, so F7. We will push EBP, do these, prepare all of this, and now we can see that this is where the destination is. So let's go to that in the dump area. So this is where we will be writing our 28 bytes, okay, starting from this location. So now if we do F7, I don't want to do that. I want to skip over it. So I'm going to do F8 to jump over. Okay, the str copy happened. So we can see our 28 bytes got copied over here. Now let's just continue. This will do the my function 2, which is just going to do the print. So I'm going to jump over it. I don't need to do that anymore. We know what's going to happen. Nope. Continue, leave. And now the return will take me back to the main function. But since we overwrote that with 28 bytes, as you can see here, it corrupted everything, so it didn't know how to go back. Okay, it didn't know how to go back, and the application crashed. So what we want to do now is add more bytes. Let's add more bytes here probably. So instead of 28, we will add more bytes, but this time uh, let's do b multiplied by, let's say, 40, for example. Okay, and then F5 again. Now, oh, sorry, what happened here? Didn't I? Why did it say? I think I didn't calculate the other part of the buffer, right? Length of buff. So buff should be now. Why did it say? Oh, this is the old one. Sorry, 68. Oh, 86. Yeah, 68. Sorry. In Arabic is we read it from the other way around. So it's 68. Okay. So let's go back. And let's go continue our execution. So F9 will bring us here. Okay, we want to jump over this one. I will also, we couldn't jump over it because we have the breakpoint, but anyway, let's continue. I'll just jump over the other one. So now we can see that our stack got overwrote with all of these A's and B's, which is what we want. Jump over, return. Now we have our B's, which will be written in the stack here. So we controlled EIP with the B's. And if you look at the values before, so what happened here is we have, so this is crazy situation, by the way. What we have now is if we send 4, 4, 4, 4, that's 16, 20, 24, 28. So if we send 28, we need 32 and then 36 bytes to overwrite EIP. But if we send 24, let's do it like we did last time in our second video. Again, this is trial and error. So let's do this one 20 and this one let's leave it 4. Okay, so F5. Let's go. See, we have 24 bytes. Okay, let's hit run. Okay, I want to remove the breakpoint so we don't need, we can jump over it. F8. Okay, so we are now here. Jump over this one, jump over this, and I want to jump over this one also. Don't want to do it. I just want to do a quick test. And so we can see we are gonna jump to this location, move, leave, we'll do that, and yep. So again, see, this is sometimes again a funny thing that you might need to, that's why sometimes you need to do multiple tests. So you can see here this time when we sent 20 bytes, we overwrote the buffer, and then EBP and EIP, sorry, EBP, and then this one is overwrote EIP. So that's why now if I, let me just do this so we can go back to the top. Now if I do F7 for the return, this one will be copied into EIP, and then it will try to execute that. So we got that corrupted. But when we sent more than 24 bytes, we needed to have a different story. We needed 28 bytes to overwrite this. So keep that in mind. Okay, so let's go to our next part. So I usually do it this way. I like to write them in exploit 1, exploit 2, and that way, even when I go back and read them, I can understand what happened in each one of them. So on this one, what we are going to do is we are going to put A's, then 28 A's, okay? And then we are going to put, let's put here the B's, let's put 4 of them here in this part of the test, actually, we need to find the jump ESP, and then I'm going to add some knobs over here. We're going to add some knobs over here to just show fill in some buffer and show that we can slide through that and on the stack and work on it. Let me just turn off my phone. You can see that. You can, or I mean, you can hear that. So what I'm gonna do now is, yeah, let's run this one and see what's gonna happen. So we should control EIP with these bees, or I don't know, we'll see that in a minute. So let's run. Okay, so 52 is the buffer. And if we hit F9, we will stop at our push, jump over it, and then we have this. Let's go into it. This time I just want to check a couple of things. So str copy, this is where in the dump we can see this is where the values which the source is pointing to is going to be written. So if we do jump over, I don't want to go into the details of str copy. Yep, the values got overwritten, so we can see the A's, we can see the B's, and we can see here the knobs, no operations. Okay, so let's continue. And here I'm going to jump over this. I don't want the print message. We can see the fancy print message here out, but I don't want that for me. Let's do knob, leave, and then return. We'll put the bees, great. So it will put the bees into the stack. So it's going to put the bees, sorry, into the EIP. So when we do the return, the bees are going to be copied into EIP, and EIP will stop. It cannot, it doesn't know how to proceed. So if I do that, see, and if I do F9, it doesn't know how to continue. Great. So all is working correctly. Let's go to here. Why? Because we need to find a jump ESP instruction. Maybe let me just show you again why I want the jump ESP instruction. Probably I didn't do that. I'm sure I did it somewhere, but maybe not here. So let's do it again. Okay, get this running. Come here, you guy. F9. Let's go jump over all of this. I'm gonna jump over all of them for now and see. So what we can see here is if we look at the stack, where is it pointing? It's pointing to FF10. FF10 is this one. What's at FF10? It's our knob values. It's our knob what instruction, I mean. So what this means, if I can find an assembly instruction in memory, somewhere in memory, which is jump ESP, that means I can call the code in here again. So what we need to do is replace this with the address of a jump ESP. Why jump ESP? Because we can see ESP is pointing to our code. So if we replace this with our malicious code, it means we will be jumping into this area and we will be executing our malicious code. Got the point? If you did, let's continue. So now I forgot to do the jump ESP. Okay, no problem. Let's just run it again quickly. And that's my fault. Sorry about this. So we have F9. Okay. What did I do? I don't need the graph now. I'm not sure what I'm pressing. I will just continue. Okay, jump over this. Jump over this one also. We know because what's going to happen, and we can see, okay, great. So let's go to the executables. Let's find a jump ESP. So we can go to nt.dll. Actually, let's first look in the code itself, because that's the best way, the best location to search for this. But probably we won't find it. So jump ESP, because I did that in previous video. So we can see item not found. Okay, so we have no jump ESP in test. Let's do ntdll and then search for jump ESP. So we have one. We can take this one. So let's copy it and let's put a breakpoint here. Okay, let's copy it and let's put a breakpoint at this location. And where is this? Yep, so we have that. Let's go ahead and now start our application, but this time what we need to do is modify our code. So instead of these 4 B's, what we will be doing is we will have our jump PSP code, the memory address for jump PSP. So let's copy this here. So this is jump PSP. Now, one thing you need to remember here, this is little endian. So as we said, least significant bit first. So we are going to do 10, and then this is in hex. So that's why we put the /x, and then 77, and then close that. So let's just double check. 34, 10, 4F77. Great. Let's do run for our code and see what's going to happen. Okay, let's make sure we have a breakpoint at our address. So we'll go there. See, we need to put a breakpoint. All good now. Let's go back. F9. Okay, we are at the code. Let's jump over this one. I don't want it. We can jump over this one as well if you want, but we can also go into it and see the str copy. So now we have this address. Let's go to dump, check it out. And now if we jump over str copy but execute it for sure, it copied the values. So the values got copied. We can see the address of jump PSP, and then we can see the no operations. Great. If we continue, I don't want to do this because it's only going to print a message. Let's jump over it. Again, you can see the message. See, it's a nice one. And then now, where are we currently? We are at this no operation. Okay, so nope, leave. What will leave do? Again, it will clear the stack. Look at EBP now. Look at EBP. It's overwritten with those ones. And now what we have, look at on top of the stack. What do we have on top of the stack? Where did we see this value? Isn't this value, which is the address of jump PSP? 77 F1, sorry, 77 4F 1034. So it's the address of our jump PSP. Great, everything is working. So let's continue. If I do continue, okay, so now I'm at the jump PSP instruction. So what is this gonna do? It's gonna tell the system, hey, go and execute the code here. So if we have, what do we have here? We have our knobs. So if I do continue, we are gonna see now this is what we call a knob slide, and we usually put those so we can slide and then have our shellcode after that. So when the CPU jumps into this area, it does nothing. So it will just continue execution until it reaches the shellcode and it will execute that. So let's modify our code. We now know that we have access, we have control over this, and we have access somewhere in memory, which is where our no operations are, and we can execute that code. Okay, all seems good. Let's close this again, and now let's go modify our third exploit. So the third exploit is where I introduce the shellcode. I will just need to copy this address here because this one was from an old test from my other video recording. So let's just replace this. Yep. And now if we, what did I do? Sorry. Oh, I forgot to replace add the shellcode. So yeah, let's do that. And let's keep the shellcode. So this shellcode is 113 bytes. All it does, it will call calculator. So it will run the calculator. And for this video again, this is the first video on the exploitation. So we're just gonna run calculator. We'll do other things later in other videos, but for now that's what we will be doing. So fill in, this is to fill the buffer and overwrite our EBP and stuff, and then this is to overwrite our EIP. Okay, and then this is some no operations to have the slide, and then this is where our shellcode is gonna be. And then again over here, as you can see, if I just maximize this, please go ahead and maximize. We can see call to test and buffer. Okay, let's get stuff going. and we can close this. We don't need it anymore. So if we do a 5 now, telling us the buffer is 154, and now let's double check we have our breakpoint here. Just, yep, see, it's not there. Just to make sure everything is going as planned, run F9. I'm gonna continue, jump over this, jump over this, jump over. Now this one, let's take just to see what's gonna happen. Now this is our location. Let's follow it in the dump. We can see this is where our code is gonna be written, which is actually on the stack. So it's the area where the stack is located. Jump over. We see it has got overwritten, and this code is actually for the shell code. I think we do have enough space here to run the shell code. And also in this case, I did a lot of tests. We need a small shell code. I will explain later on how I got this, how it was made later on. But for now, I will just continue. So continue. We don't want to call F2, my function 2, I mean, because it's gonna print this fancy message or whatever it is. And now if we do the leave, what the leave is gonna do, as you can see, it's gonna clean the stack frame. Now what's on top of the stack is our jump address to jump PSP. So we are gonna go to jump PSP. Now if I take the jump PSP, we are at the snobs. Now if I can just go F8, I can do that, or F7 I mean, or I can just hit F9 and it should execute the code, and we get our calculator. So this calculator was actually executed, or it was run by exploiting the vulnerability in the code and using it to run the calculator. Now a threat actor will definitely not be running a calculator. A threat actor or exploit developer is more interested in running a shell or a reverse shell or any of those, which we will explain later on in other videos. So let's close this and let's modify our final one. So we know our code is working. Let's just go to the final one. I just want to do one basic change in the final one. And so we have to take this address for, yeah, let's copy this one, all of it. I can replace that because again, this was from an other test, previous test. Okay. Did we copy this twice? It seems, yeah. So we have this, we don't need that. Yep, so we have that. And now what I'm gonna do is I'm gonna call test directly without the debugger. So I'm not gonna call the debugger anymore. I'm just gonna call test with the shellcode, with everything, and see if it works. If our exploitation was done properly, then we should be able to get shellcode, run the calculator without the debugger anymore. And this is a 5, and we get our calculator. So again, we managed to exploit the vulnerability in Test.exe. If you remember the code from Test.exe, where is it? Let me save this actually. It's good to go back to sometimes. And let's say this is notes. What did I do? Where is this? Yep. So let's say this is notes. I don't know what those are. Okay. So if we go back here, oh, what are these EA edges? I don't know. I didn't see them. But anyway, if we go back to our code, edit, we can see this application is vulnerable because this copy instruction really doesn't check any boundaries. So it doesn't check if the source and the destination are, their sizes are equal or not, or less or equal. So it just takes them and copies them, and that's why we managed to copy our shellcode into source and then copy it onto the buffer, which actually overwrote the buffer, and that way we managed to run our shellcode, which in this case was the calculator. Again, if you run this again, the code again, F5, you should get your calculator, which is pretty cool. Great. So that's it for this video. Okay. I will see you in other videos in the future. Thank you for watching, and see you soon. Bye-bye.